everybody, Fraser here for a live episode of the Weekly Space Hangout here in Edwardsville, Illinois, as part of the Astronomy Cast 500 celebration with what's got to be 40 of our closest friends. But joining me in person for the first time that I've ever met her, Dr. Kimberly Cartier. We got Dr. Morgan Redberg.
Howdy.
And Dr. Pamela Gay. People are saying the audio's low. Try turning up your volume. There's only one audio, so it's...
No, it's not slid all the way over. So, yeah, slide the slider underneath.
Chad.
Sorry, Chad.
Do you see it just below the green? And Chad!
I don't know where your mouth... There. That. Move it all the way to the right. All the way to the right.
Turn into 11.
There we go. We should have audio.
There you go. Might be...
Okay.
Might be...
Tell where Paul is.
What?
Explain why Paul's not here.
Oh, yeah. Paul's
Paul?
busy?
Paul Matt Sutter?
Yeah.
Paul Matt
So
Sutter.
So Paul Matt Sutter isn't here this week because he's getting ready to go on the cruise, which Paul and I are doing in about 5 days. So he's got his whole other adventure planned. So we swapped out one PhD astronomer with another one. They're interchangeable.
Hey.
Paul and Fraser live the cruise lifestyle now, so you gotta pin them down on dry land when you can.
But so this is the first episode of the Weekly Space Hangout. I'm sure this isn't going to be our best one. This is the one that we're trying to do live from a bar in Edwardsville. But we do have some crazy news, and we know you've been jonesing for your space news, so we wanted to bring the whole team back together, especially meeting for the first time in most cases, and do a show with you. So let's get on with the news this week. This week we're going to be talking about the stuff you all want to know about. The ISS whole conspiracy.
Was it aliens?
Was it aliens?
Aliens.
Why did the FBI shut down the Solar Observatory?
It was
Was it aliens?
It was not aliens.
What happened to Opportunity?
It was not
Was it
aliens.
aliens?
Yeah, so we hear back. I see how this works. Crazy hexagonal storm on Saturn. Jocelyn Bell wins a prize after all. And Comet 21P that you can see in the night sky. So, where do we start? Okay, let's start with this crazy hole that's on the International Space Station. Air leaking out. How did it get there? What's going on, Morgan?
Oh my God, I have been waiting to talk about this story for ever. Maybe my entire life. So, a few weeks ago, air leak on the ISS. Not emergency. They tracked it down. This is like how I know I could never be an astronaut. Because you're like, your air is leaking out. Now you're going to track it down inch by inch across the space station. But they figured out that it was a hole in the Progress capsule that had been docked to the ISS, had brought supplies. And they took pictures of that hole, they sent it back to mission control, and I don't know, they put duct tape over it apparently. Because that's how you fix things in space. And once people started looking at the hole, it started to seem kind of weird. Because it's like perfectly round. And their original guess had been that it just got hit by a micrometeorite, which is kind of a constant danger on the ISS. But the hole is perfectly round, and most meteorites are not perfectly round. And so it started to look basically like somebody had drilled it. And there were even some sort of like scuff marks around the hole, as if somebody had kind of missed with the drill and then finally gotten through.
Finally drilled a useless hole
Exactly.
on the space station.
And kind of the original working theory was that somebody in the Russian Space Agency building the Progress capsule had sort of accidentally drilled a hole in it and was basically too afraid to tell their supervisors, and they like plugged it up with super glue. And off went the rocket.
But what really happened? Tell me what really happened.
What really happened was NASA drilled a hole in the Progress capsule to evacuate the space station so that aliens could take it over. So they could bring a sick astronaut
back to Earth.
Because all it comes down to is dollars and cents, according to Roscosmos. Because it costs about $85 million for NASA to send astronauts on a Russian Soyuz capsule up to space. And if they brought astronauts home, they'd have to bring 3 of them home to make sure that there were enough escape capsules left on the ISS to bring everybody else home. And then they'd have to send some of those astronauts back on another mission. And so the allegation here is that NASA basically sabotaged the space station to save, what's basically chump change to the space agency, and that makes more sense than any other possible explanation.
Right.
Yeah, clearly couldn't have been human error at all.
Well, and we missed what was maybe the best part of this whole story, which is when they were still going with the first story, which was that a worker had drilled a hole by accident. They put out a press release saying that they had found the worker responsible and terminated him. And what does that really mean when, a Russian official says he was terminated? Is he alive? Is he dead? It's kind of...
Has anyone pointed out that the reason craters are round is that when something stops suddenly, the energy goes out in a shockwave which is always round, and that a micrometeorite moving fast enough will always make a round hole?
That's not a realistic explanation.
Yeah,
it was
yeah.
obviously a drill smuggled onto the ISS to sabotage a spacecraft, to bring an astronaut home, to save a few million dollars.
10 years of education, and all I needed to do was watch the right YouTube videos.
The thing that was really fascinating, people were wondering, if this was a real thing. All of the air was very slowly leaking out of the space station. The solution was duct tape.
Yeah.
And a lot of people just didn't believe that you could patch up a hole that small on the space station. Like, why were the astronauts sucked to the wall, extruded out of the space station like spaghetti?
Spaghetti.
Right?
Yeah.
One after the other in this horrible mass, and that was the end of them all. Why didn't that happen?
Pressure. It wasn't a sudden loss of pressure. It was a gradual loss of pressure. And had they waited forever, they would have lost air, but they never, the sucked out spaghettification approach only really would work if it was kind of an instantaneous loss in pressure.
Cody from Cody's lab, he built a vacuum. Scott Manley asked him to do an experiment to show people how not dangerous this hole was. So he's got a vacuum chamber. So he built a vacuum chamber, sucked out the air from a plastic bottle, punched a hole in it the size that was on the International Space Station, and just closed it with his finger. No problem, no pain. Didn't even get a little blister on his finger. He's like, I can feel it, but it's no big deal. And he would put his finger, air would let out, air would go back in, and then he put the duct tape over the hole, sealed up perfectly. That, no problem. So those astronauts, they've never been safer than a chunk of duct tape.
I think they were safer when there was an actual wall there.
Now they've got duct tape where there was just a regular wall, and that's a regular wall.
But you should still have a wall between you and space. That's still the preferred method of
the
being
duct
in
tape
space.
is the better kind of wall.
It's not better than the actual wall. It's not better, but it is good enough. It is
You will
good
never get me into space with a duct tape rocket, okay?
With a duct tape rocket and a big wall.
Give me a wall,
So
please.
as fun as this story is, there really is kind of a sad side to this story, which is over the last 20 years, and the ISS has been in space almost 20 years now, it has served as sometimes the only point of cooperation between the US and Russia, and really a place where the scientific communities could come together, where the space agencies could come together, where in some ways foreign relations could come together and have even a single point of cooperation between two countries that are often at odds. And it's a real shame to see what has been such a successful partnership in the last 20 years start to fray. And there's no doubt that allegations like this, as silly and laughable and fun as they might seem, are a threat to the credibility and the sustenance of that relationship. And it's, in the time in which it feels like many of our foreign relations are in strain, to have something that's been so solid be suddenly so up in the air it's a disappointment.
It is a peacekeeping mission. That's, at the end of the day, the International Space Station is a peacekeeping mission.
Sure. So people are, if you're on your Wi-Fi's right now, if you can turn off your Wi-Fi's, that would be helpful, because we're gobbling up all of their Wi-Fi here. Everyone go into airplane mode.
Yeah.
Just temporary.
Even me on my phone, just for a little while, because it looks like it's crap. But we're recording it locally, and we're recording the audio locally, so people will get it after the fact as well. All right, so let's move on. That's not the only weird conspiracy that's going on.
Oh God!
Give me more
the second one, and this
conspiracy.
was funny. This came. A lot of people were posting comments on my YouTube channel, and I didn't know what they were all talking about. People kept saying, "What's going on with the National Solar Observatory?" Pamela, what's going on with the National Solar Observatory?
So, the United States Solar Observatory has facilities in a variety of different places. Kitt Peak has one. There's a bunch of places that together these networks of facilities make it up. Now, one of their facilities is located out in New Mexico. It's the same ridgeline that we also see Apache Point Observatory. This is where the Sloan Digital Sky Survey is. This particular facility also looks out on White Sands National Park and White Sands Missile Arsenal. Now, for unknown reasons, leading to vast amounts of speculation, the entire facility was evacuated by the FBI. We're talking, the FBI came, they said, "Thou shalt leave." They didn't arrest anyone, they didn't take anyone, they just kicked everyone out.
Black helicopters in the night kicked them out.
Pretty much.
Yeah, they had one Black Hawk helicopter come in. Yeah, evacuated the whole town.
Yeah.
Yeah.
And there's like people that live there. This is your mountaintop observatory, maintained all the time, long timeline data. And no one knows why. All that the FBI is saying is security. The Association of Universities for Research in Astronomy is simply saying for security. And no one knows in what sense the word security is being used. So I'm going to quote a fabulous tweet that I saw coming out from the good folks at
Something having to do with foreign hacking.
Yeah.
Given that there are already so many lines of evidence in so many different arenas for that kind of cyber warfare from foreign hostile powers and things like that. It's all over the place. If I were to guess, I would say that's the most plausible, just given the environment that we live in now.
Yeah.
And astronomers are not the most security conscious group.
No.
And we do travel all over the world to go to various conferences.
Yeah.
A few years ago, I went to Moscow for a COSPAR meeting, and before I left, because of an amateur astronomer who's in the FBI who put me in touch with the local folks, I got debriefed on how to keep myself safe. And what I was told was, do not accept a USB drive from anyone, which is good sound advice to all of you. Do not accept a USB. All it would take is one astronomer handed a USB drive by another astronomer who had a co-opted drive, and thus they're in.
When I was working at the Laboratory for Atmospheric and Space Physics in Colorado, we had special loaner laptops that were given to us if you were going to China.
Yeah.
And you weren't permitted to bring your work machine, because a lot of stuff that intersects with astronomy also intersects with defense in terms of missiles and satellites and things like that, rockets. And so, there is a plausible pathway, but only sort of. It's really kind of mysterious why hacking the National Solar Observatory would be effective to get you anywhere else. And I think that's kind of the big question. There's not an obvious, it's not like we're logged into, defense networks or anything.
Yeah.
So what is the vector of attack from NSO to anything that's actually worth
Except they've got telescopes
you can
that
just
look down at the White Sands missile range.
Well, but the National Solar Observatory telescopes don't. They look up, and they're not like normal telescopes.
Yeah.
Look at the sun.
Like Apache Point, that would be a slightly different thing.
But it's on the other side.
But the NSO, those telescopes don't look like telescopes.
Yeah.
And they're pointing into space.
Yeah.
So if it was aliens,
They definitely had 3 legs. That's just obvious.
How would this cover up play? What would they be doing there? How would they be covering?
Taking the body to Area 51.
So there was a science fiction book that I read. I think it was a Neil Stephenson one, where one of the plots was that there were aliens that were monitoring the Earth from right next to the sun, and you lost them in the solar glare, so you couldn't actually see them. Except then something happened, and they used nuclear explosions as their engines. And so maybe there's aliens in that gap between the surface of the sun and what you can see with SDO that they're hiding out in, just like in this book.
So is Parker's solar probe going to reveal the aliens?
Yes, it's going to in fact encounter them, and it will be first contact.
You heard it here first.
Lies. This is all lies.
Yeah, like what could you see on the sun that you can't see with any of the other millions of telescopes pointed at the sun?
I mean, that's the thing.
Nothing.
Which aren't as powerful
Nothing.
as some of those other ones. Yeah, I don't know. All right, let's move on.
Can we not talk about aliens for a little bit?
Yes.
Thank you. I'd
So the
appreciate
next
that.
topic, I'd like to talk about aliens. No.
I'm gonna go get a drink while you do that.
So, Jocelyn Bell.
Yes, so a story that actually makes me smile, something that fixes a problem that has been 50 years in the making. So going back 50 years ago, or a little more than 50 years ago, 1967, yes, Jocelyn Bell was observing with a radio telescope and looked up at the sky and saw these regularly repeating signals coming from the sky. And then she saw more and more and more. And now we know of these things as pulsars.
Hold on 1 second.
No, that's not.
What was the acronym that Jocelyn Bell gave these strange objects?
They were called LGM.
LGM. And what does the LGM stand for?
Little green men. Okay. They're not aliens. They are pulsars.
That we know of.
That we know of.
Fine. Moving on. They are pulsars. Dead neutron stars that are spinning so fast that they flash beams of really intense radiation past Earth regularly. And this was an amazing discovery from space. And not a decade later, her advisor, not her, won a Nobel Prize for the discovery of pulsars. And it's one of those moments where you realize that, you know, an incredibly important discovery in astrophysics was made, and the woman who discovered it did not receive credit for it. And that was 50 years ago. And just now, this year, Jocelyn Bell Burnell won what is called the Oscars of Science, the Breakthrough Prize in Fundamental Physics, which is a $3 million prize for this discovery of pulsars. And it was just such an incredible feeling of relief for me personally that, you know, this incredible discovery by this incredible woman scientist was finally recognized in the way it was deserved. And what's even more incredible to me is that instead of, you know, investing this money in research or in her own personal finances or anything, she decided to give away all of the prize money and start a scholarship for women in science and to combat unconscious bias for underrepresented minorities, for women, for immigrants and refugees, trying to level the playing field in science. So not only an incredible recognition of wonderful science by a woman, but then giving back to the field and trying to, I guess, prevent these sort of things from happening anymore.
There was a fabulous interview about this that I don't remember if it was on NPR or BBC, and the host asked, well, you must have been upset to not get the Nobel Prize, and it was phrased in a very leading way. And Jocelyn basically responded, oh, no. Back then, I knew that the student would never receive the award. And she went on to explain that this has actually been a bit of a good thing, because if you get the Nobel Prize, no one gives you anything else again, because they're like, our little award doesn't matter, they have a Nobel Prize. And she said that for the past 40 years, every year or so, she's getting another major award. recognizing what she was able to do. So not getting the Nobel Prize has actually opened a lot of doors for her to get other opportunities and awards.
Yeah, and she's had an incredible career in research science since then, and also as a leader in the community, giving back in so many wonderful ways, and going on to be, a pioneer in science just beyond pulsars. And I can't think of one instance in the past 50 years where she has expressed bitterness or regret that she never received that prize. But I think the one sort of bittersweet part of this to me is that, yes, an incredible woman scientist won this award. I am so glad that she has received this recognition, but it makes me a little bit sad that she felt that the environment was still not good enough, that someone like her today may still go through the same experience that she did, and that she felt she had to give away the prize money and couldn't to combat this, as opposed to a lot of male scientists who don't, who invested in their own personal careers.
Yeah.
I mean, it's great that she's giving back, but it's still a little bit sad that she felt that she had to.
This problem of a lack of recognition is one that I think we're only really starting to grapple with, and you could give one of these awards away every year, maybe every month, for the next 50 years, and only start to kind of give credit where credit is due for the pioneering work that has come in the last 50 or 100 or 200 years of astronomy. And so it's a great thing to see that happen, but it's not enough to see that happen. And we can't let people like Breakthrough off the hook for having done it once. It needs to happen again next year, and again the year after that, and again the year after that. And not just this award, but other awards, including the Nobel Prize, which is still awarded to women across all fields at an incredibly low rate, long after sort of that fact entered wide public consciousness. And yet that pressure really hasn't resulted in anything changing. And we really ought to sort of reevaluate the standing and consideration that we give those kinds of awards if they're going to continue to behave in that fashion, because it's not worth recognizing them as recognizing great achievements if they're going to box themselves in to what is really a pretty small part of the amazing achievement that happens in science.
And this is something that's happening in a lot of subtle ways as well, because it's not just women, it's people of all intersectional ways of coming together that is slightly different than what is expected. It can be something as minor as Lemaitre. He published in French and his work went unrecognized, and the Hubble Law was called the Hubble Law, and now they're recognizing his efforts that were in French. If it's as subtle as you're a white guy who published in French, think of all the other ways the biases come up. Recognizing them is the first step, and I have to say kudos to all the places working to recognize and change how we see our universe and the people who discovered it.
And one of the other great parts of this particular story is that when a scientist wins the Breakthrough Prize, they then, for the following years, become part of the committee that helps select future recipients. So now not only is Jocelyn recognized for her work, but now she will be able to more actively help with the nomination process and with selecting future recipients and take a more direct role in that, which is a wonderful achievement.
Yeah.
All right, well, let's move on to sad and scary news now, which is the hunt for the Opportunity rover. And as everyone recalled, I think we were still reporting on this when we were still doing the Weekly Space Hangout. I'm not entirely sure.
Yeah,
in the summer.
The dust storm on Mars has been started in May, in early May.
Yeah.
So we were still going. When we stopped in June, it was still going.
Yeah, and we knew we were going to lose the Opportunity rover back then.
Yeah.
I would have thought that we would have heard from the rover. The big storm on Mars has mostly settled down at this point, but here we are. into September. No word from Opportunity yet, and now
Yeah.
the search is getting pretty serious. The weather conditions on Mars have settled down to the point that Opportunity should be capable of recovering. And this week, NASA began their 45 days of attempting to contact the Opportunity rover. So they're going to send a signal every day for the next 45 days and try to get a return signal back and hope that the rover was able to survive this storm. And the problem is that, I mean, Opportunity should have been gone a long time ago.
It's
When
almost 15 years old,
Yeah.
and it was supposed to be what, a 90-day mission.
A 90-day mission.
90 days, and
Yeah.
now we're 15 years
But
out.
it wasn't going anywhere. It was supposed to stop working long
Yeah.
ago.
Yeah. And pieces have slowly
Yeah.
started falling off.
But I mean, obviously the engineers knew that it was going to last a lot longer than it did, and so the big problem was that Opportunity has electronics inside of it that can never go below a couple of degrees below zero, no matter what. And so it has a couple of little pieces, little pellets of decaying plutonium, like the nuclear RTG battery that Curiosity has, but they're these tiny little pieces, and their only is to keep the whole thing warm. As well, it uses its batteries, and so it would charge up its batteries fully, and then slowly run heaters over the course of the time that it was going to be out of not getting a lot of solar energy, and then that's how it would try to keep its electronics warm enough to weather the storm. Now, because it's so old, the batteries are down to in the high 80%, which is kind of amazing that they've run these
Wish
batteries.
my phone would work like that.
Yeah, and
Yeah.
they've only lost that amount of battery capacity, but that seems like that's enough. And this storm was the worst storm that's ever been seen in modern history on the surface of Mars. So you got these two combinations coming together. Curiosity's fine. It's got to dust off the dust on itself, but it's running this nuclear battery. But Opportunity needed
has
the
the
solar
solar
power.
panels.
It needed it.
Yeah.
And so we're looking at 45 days.
So
and
what
then
would
they're going to
happen
declare.
after 45 days?
You're saying they're going to declare it gone.
Well, they're not going to declare it on. So my understanding is they're going to do 45 days of active listening. This is where they both listen and send signals, which are signals the mission is listening for and will respond to if it gets them. After that 45-day window, they're going to go to passive listening, which is just on a regular basis looking to see if they can hear it, but probably not using the full big ear to do it. Now, one of the things that I've been reading, and Emily Lakdawala and the folks at the Planetary Society have done a lot of really good science communications about this. One of the concerns is that there's a good chance that our little rover was left with a solid coating of dust, and it just needs a gust of wind to blow off the gust. Now, these kinds of gusts occur on a regular basis, and from running models of how often these things happen, how much dust there probably is, a lot of the people associated with the mission would like to see the active listing period extend all the way out to January to give it a better chance. 45 days is generally considered by almost everyone, except for maybe the budgeters, as just far too short a period of time to give the rover a chance to charge up with dust on it, or to have a chance to have that dust blown off and make it easier for it to charge up.
So what do you think? Place your bets.
I say it'll come back. It's
Yeah.
lasted this long. It is
It's
very
undead
hardy.
now?
It's like a brick.
Can't die.
It never dies. It's
Yeah.
a brick.
Yeah.
And as long as you get the solar panels working again, I think it's probably pretty likely that it will come back, that there hasn't been some hardware failure along the way. You just got to give it time. Plus, it's in Perseverance Valley.
And even if it does, is it enough passing through to the solar panels, enough light passing through to the solar panels to kind of get things kick-started again? And, I don't want to bet against it, but I would say, 50-50 is probably about as good as I would give it.
This is the way they thought the rovers would die.
Yeah.
They just weren't anticipating the cleaning events. And the cleaning events, it's not just wind. Like, there's something to do with the magnetism as well. So there's actually there's some kind of electrostatically charged. The dust is getting almost like the the way the
It's
dust is
frictionally
interacting and the way it's friction. Yeah, the way the winds are blowing, the way the dust is being moved frictionally is causing electrostatic interaction, and so there's you gotta have not just wind but like the right conditions to be able to help discharge the panels to be able to then get the wind off.
And that
It's almost
electrostatic force is weak and
Yeah.
can't loft more than individual dust particles. If you get a layer, it's not going to levitate
Yeah.
a layer to be blown away.
Yeah.
It only works right at the surface.
And so
very
this is
faintly.
something that we've never been through
Pessimists.
before, right? Was that the cleaning events were coming through so often, but now we've got what is probably a much larger amount of dust. So I feel, but obviously there's no scientific reason. I just feel like that's it for opportunity.
So
Family.
after the stuff I've read, I have this terrible feeling that there's going to be a dust removal event in November, right after the end of the 45 days, and it's going to try and phone home. And in my science fiction reading universe, there's some super amazing amateur astronomy network using Dwingelo Observatory that hears the little rover, and then NASA's already cut off the funding. I don't know. I'm seeing some future version of The Martian, except about rescuing this rover.
Back in the table.
Sorry.
Um,
Well, I'm glad
So-
you didn't leave me out in the dust.
so
Sorry, I had to.
now you said like
joke.
NASA cuts the funding. So what happens if NASA actually cuts the funding for the rover?
All the human beings that work as rover operators for Opportunity move to other projects. And if there isn't space or funding on other projects, we don't talk about that.
So there would just not
So it
even be a
could-
skeleton crew. Nobody's going to be listening. They
Right.
will turn off the computers and they will no longer listen to Opportunity.
Yes.
Yeah.
Yeah.
We've abandoned working satellites in the past
Why?
because you have a limited amount of funding and you have to allocate that towards the most effective and also interesting to science, but also to the public collection of missions. And at some point you have to decide, okay, we can only hold on so long before moving on to the next science challenge. And Opportunity has returned so much science about the surface of Mars that it would be easy to see it as having gone way above the call already and it being time to look at something else.
And let's face it, currently we're dealing with cost overruns on James Webb Space Telescope that we have to find funding for, and so many other programs.
Yeah.
We can't have all of our toys. We just can't afford to replace their batteries, basically.
So is
Very
James
sad.
Webb gobbling up the budgets of all the stuff,
Of everything.
of everything?
Let's not talk about James Webb.
All right. Well, let's move on then. So let's talk about this crazy hexagonal storm on Saturday. Do you want any notes for this, Morgan? Or are you good?
Well, you can correct me when I make an error. So I think we've all seen pictures that Cassini took of these amazing hexagonal-shaped storms on both the North Pole and the South Pole of Saturn. And they're really kind of a mystery because we've also seen these pictures of wow, this is real low-tech. We've also seen pictures that Juno has taken of the poles of Jupiter for the first time. They look nothing like that. No hexagonal storms. We really haven't seen the poles of Neptune or the north and south of Uranus. But there's no real reason to think they look like that. So this is kind of a Saturn unique mystery. And a lot of questions have been about sort of how they form. And we've done experiments in the lab suggesting that differential wind speeds could create that hexagonal shape, but we really need a lot more data. And Cassini's obviously done now, so we're not going to get more data because the telescopes on Earth can't see the poles of Saturn. But reanalysis of some Cassini data has given us an interesting tidbit, and that's that these hexagonal storms, specifically in the North Pole, might be raised up above the rest of the cloud layer of Saturn, hundreds of kilometers high. And the way they figured this out was really, really cool. So Cassini had an instrument on it called SEERS, the Composite and Infrared something spectrometer, I guess IR infrared spectrometer. And it's basically a thermal camera. And what they would do is they'd point that at stuff and basically measure its temperature. And because Cassini's mission was extended so much, we got through like half of a year on Saturn. And we were able to start seeing summer come to the northern hemisphere. So Saturn to tilt towards the sun, and just like here on Earth, when it's summer, it heats up. And so as they were pointing seers at Saturn and making temperature measurements, the atmosphere was heating up. It's just so neat that this is sort of a discovery, a phenomenon that has unfolded before our eyes in the last 15 years in a way that these things very rarely do. Often we're going to go somewhere kind of knowing what we're going to be looking at and what we think. Like, we're going to go to Europa because we think that there's water underneath its surface, and we're going to make these measurements, and they're going to tell us these things. And 8 out of 10 ideas we had are going to turn out to be right. That's a lot of space exploration in the sort of post-Voyager era.
Well, I mean, like, nowadays, that's how you get things funded.
Exactly.
You have to be able to say, this is the science that I'm going to prove, and this is the instrument I'm going to build to do this particular thing. Rarely nowadays do you ever get the just, let's spend a bunch of money and put a thing out there and see what we see. And we had this discussion when Cassini had its finale. It's one of those, it's the last vestiges of the let's explore the unknown.
And hasn't it paid off with an incredible bounty of just objectively cool things?
But the fact that these storms on Saturn are so different than the ones on Jupiter, like, I don't know, they found that Jupiter has a second south magnetic pole. It has two south magnetic poles, one at the equator and one at the South Pole. And we know so little about Uranus and Neptune. And they're, being able to study these worlds in comparison is a thing that's so important. And it's really sad. We've got so much information about Jupiter and about Saturn, and almost nothing about Uranus and Neptune.
Yeah.
Like, we treat basically all large exoplanets as being the same.
Jupiter.
Yeah.
And oh my gosh, isn't there such incredible variety amongst the planets in our solar system? And in fact, we think Uranus and Neptune sized planets might be the most common in the universe, and we know nothing about them. They're blue. That's 30,
Ours are blue.
30% of that's 30% of what we know about Uranus and Neptune in our solar system. Odds are they're totally different worlds, and that's what we're learning with Jupiter and Saturn.
So we got time for one last story, and then maybe we can grab some questions from people. People want to know how tall Kimberly is compared to Morgan.
I'm 5'2".
I'm tall enough that you don't have to count.
Yes.
He's tall. He's tall.
Sit up straight.
But so the last thing is just to mention is just this comet. There's this great comet that could be approaching visibility. You can see with the binoculars right now with the small telescope, 21P. It's moving, sort of. It's rising later and later in the night. Right now, you kind of have to get up in the morning to see it, but it's hoping in the next probably half month or so, it's going to get even bright enough that maybe we can start seeing it with the visible eye, which, we haven't seen a nice bright comet. It's a fairly common one, 21P. It comes back on a regular basis, and it's just great that things are lining up that we're going to get a really good view of it. So this isn't that amazing bright comet that I've been promised for years and years, but it was great. I got a chance to view it in the telescope. I've taken a picture of it.
Are we going to see it at the star party tonight?
Well, it's going to be like 4 a.m, so I don't think so.
Not me.
But yeah, so if you want a challenge, take your binoculars out, get up early in the morning, and you should be able to get a shot at seeing this comet. It's in a different location every night, so you gotta sort of know where to look.
Should we do some questions?
Yeah.
Question.
So do we have any questions?
Any questions here?
Live people.
They're all just stunned.
Science
Is it
or
buffering
not.
for you here in the bar? Yeah. Are you all right? So it turns out that this is actually happening in real life. It's us buffering. It's not.
There's a world beyond the internet.
Yeah.
So confused.
Let's see. Oh, and so you mentioned, Susie was mentioning, so we're going to be at the Wildly Theater in Edwardsville tomorrow starting at 10 a.m. So if you didn't know that this was going on and you still want to make it, join us for the 500th episode of Astronomy Cast tomorrow. And other stuff.
Yeah.
we have any questions from the
Questions?
chat? Can't believe no one has a
So
question.
Neil, you asked Morgan, if we ever get that Europa submarine budgeted, how long would it take to melt down through the 30 to 100 kilometers of ice?
Well, hopefully it's not 30 to 100 kilometers. I think better estimates are probably 10 plus or minus 5.
Yeah.
But even so, basically forever. You know, we've only drilled through a few kilometers of ice in Antarctica like once or twice, and that took like truckloads of equipment. So we're nowhere close to putting a submarine on Europa. What's maybe sort of tangentially plausible is this idea of basically taking a hunk of plutonium and like tying a string to it, and it'll melt through the ice over a very long period of time, and sinking that and carrying through some sort of sensor underneath the ocean. And the fact that that sounds crazy sort of gives you a sense of how plausible it is to go under Europa or Enceladus. Much more likely that we'll be flying in the atmosphere of Titan.
So there's
reasonably soon.
there's a experiment that's being done in Greenland with a heat probe that they're using to melt into the ice on Greenland, and they can actually get about a meter an hour, I think, with this thing. And so the real rate limiter is the size of the probe itself. Essentially, the bigger the probe is, the more payload that it would carry, the slower it's going to have to go. But it's going to take anywhere from 6 months to about 2 years to make its way down using that plutonium.
And let's be clear about why it's going down. It's going down because of gravity.
Yes.
And the gravity on Europa is, I don't know offhand, but I'm going to guess at least 10 times weaker at the surface than on Earth. So if it would take 6 months to 2 years to go down several kilometers on Earth, then we're talking 5 to 20 years at minimum, and space is much colder, and so probably it will sink more slowly. So even at that optimistic Earth range, we're talking decades to sink down, even if the ocean was 5 kilometers under the surface, which it
And I mean,
probably
like,
isn't.
They can try and optimize it by, finding the spots where the ice is thinnest, where the surface is warmer, or where there's cracks, where we know that there's places where it can up well, where the ocean's more accessible, but it's still going to be many years.
Submarine on Titan first.
Eris Echevarria is asking, so is SpaceX really going to land tourists on the moon? So have you guys heard about this?
Yes.
Land 'em,
Like
sure.
ever?
Land 'em, sure, but are they going to survive
No,
or
so
get
so
back?
SpaceX just tweeted, Elon Musk just tweeted a new picture of the BFR, which is the new, the new SpaceX rocket. It looks very different. It has 3 wings on it, kind of like the space shuttle. 2 of them fold, so it kind of, it's like a new shape for how the landing legs are going
This
to work.
folding has worked so well for James Webb.
Yeah. Well, so it's like the landing
Breaking
legs
my heart
will,
here.
but they'll provide some of the aerodynamic activity. And so the plan is that they say that they're gonna send someone beyond the orbit of the moon on the BFR soon. And now they're
Soon
yeah.
is when?
Well, so the BFR is expected, the spaceship portion is expected to do hot tests in 2019.
Right.
So we're just a
Okay.
year away from the BFR starting to fly. I know this is blowing your mind.
That's
right?
the spaceship part, not the rocket
Not
part.
the rocket, not the first
Okay.
stage. It's the spaceship
Not the
part.
big friendly rocket?
Yeah, the big friendly rocket. And so we don't know. They said they're going to do an announcement on Monday. But the fact that they're doubling down on so many things all at the same time. They're doubling down on the fact that the BFR actually exists and they're working on it, right? They're doubling down on this crazy idea to send astronauts beyond the moon. And the fact that now they're going to do, like, everyone is just like, come on. But
No, but my original question stands. Like, I believe that they can send people to the moon or past the moon.
Yeah.
Will
They're
they
not
be
gonna
alive
land.
when
They're
they
probably
get
not
there?
gonna land.
And will they get back?
well, that's
Those are my 2 things.
So they'll probably send them
They're-
on an orbit that's going to go around the moon and come
Okay.
back.
Sure.
Right?
Right.
And so when you think about the list of things that would need to be put in place for that to actually happen, you need to have the BFS. You need to have the first stage rocket. The thing would need to work. You would need to have a way to keep a human being alive in the BFS for however long it takes to fly around the moon. So there's a lot of to-do items. So the fact that they're going to do a further announcement in just a couple of days, okay, I can't wait to hear what the plan is, and we will definitely report on it in our usual tone,
Our
which
usual
is about like this.
skeptical tone.
Our
skeptical tone?
But remember, the Falcon Heavy launched. They
It
land
did.
rockets.
It did.
They did.
Yep.
It was glorious.
So that's where we live. We live in this weird space in between fantasy and reality.
I mean, like when his stuff works, it works spectacularly. When it doesn't, we all laugh.
Yeah.
And we're like,
They
of
just
course.
take longer than we thought.
But
When the whole idea of we live in a simulation first came out a couple of years ago, I came down rather hard on that as being not possible. And I'm starting to emotionally reach the point of hoping we live in a simulation and they'll stop dicking with the settings.
Speaking of trying to land, Hayabusa 2 came pretty close, but not as close as they expected.
Oh yeah, I've been following the story on
So-
Hayabusa too, so we should definitely cover
so
that.
the question was, or the comment was about how Hayabusa 2, which is at an asteroid right now, was supposed to have gotten much closer to the asteroid than it did on its approach. I don't know if the microphone probably didn't pick up the question from the
Yeah,
audience.
I haven't been following the state. I know that just a day ago, yeah, they've talked about that they haven't gotten Hayabusa as close to Ryugu as they were hoping to. The plan is to still land on the asteroid. Let's hope there's not a problem with that, because the Hayabusa 1 just barely limped back
Yeah.
home with micrograms of dust from its previous target.
Totally by accident,
Yeah.
micrograms.
This is a Japanese space mission. I just love JAXA.
Yeah.
They're so like Wild West freewheeling it. Like Hayabusa 1, they dropped 3 kinds of landers on the asteroid. 0 of them worked. And so they came back with 3 different kinds of landers for this one. Will any of them work? I don't know. But they had one that's gonna like bounce around. They had one that's like big wheel. It's just like all of these amazing things. Like, you know, Akutsuki failed to make its insertion into Venus orbit a few years ago. We've covered that. And yet they figured out how to like jerry-rig it back into orbit by using the maneuvering thrusters. It's kind of awesome.
Yeah.
Because NASA would never do this. The failure of Hayabusa, and it would have
like
been
shut
seen,
down all
it would have
asteroid
been
programs for the
seen
next
as a failure by
decades.
NASA, would have shut down
Yeah.
asteroid missions, and JAXA just builds another one, and it's gonna work somehow with some bit.
It's the difference between failure is not an option and dare mighty things, and we don't get to do the latter as often as we'd like. We did it with Curiosity because there's no other way to land that thing. And we need to admit sometimes we have to do the crazy stuff just in hopes that it will work.
I mean, there's no human beings on board.
Yeah, we're just going to potentially kill a robot.
Yeah.
As
And
one
even
does.
just close images of Ryugu from a kilometer in altitude
Yeah.
was immensely
Yes.
valuable for planetary science. So
I mean, I was just mesmerized by that stereo image of the asteroid rotating around, and
Yes.
you could see all the bumps and grooves and the tiny boulders and the giant mountains that live on this, little diamond-shaped asteroid as it's, spinning around. I mean, that's still incredibly valuable science.
Yeah.
and when you think about, like, say the way the Soviets attempted to figure out landings on the surface of Venus, right? They just sent spacecraft to spacecraft. They didn't know what the conditions were. They found out when they died, and then they made something tougher that could handle what killed the last one until they finally got down to the surface and could survive for half an hour.
Yeah, that would not fly at NASA today.
Yeah.
No.
Yeah.
Pun intended. That would not fly.
That would not fly. All right, so we're sort of reaching the end of our hour. We should probably wrap things up. Apologies to the everyone watching for the live stream, but we will record a version of this locally, and then we'll upload that, and it's perfect. I see it. It hasn't gone down at all.
So
We're going to be here in Edwardsville tomorrow, so if people want to watch the live show that we're going to do, they can absolutely join us.
yeah, I was to say, on behalf of everyone who has ever had the opportunity to work with Pamela and Fraser and everybody out there who didn't get to come, who's had a chance to watch, I think we just want to say thank you. It's not an exaggeration to say that I do this because of them. Pamela gave me my first start with the 365 Days of Astronomy podcast, and Fraser was kind enough to welcome me into Weekly Space Hangout when I could barely string 3 sentences together after one another. And there's so many people out there who can tell that same story. And we're all so much in debt for the way that they have their arms so wide open to the entire community, both the guests, but also those of us who get to participate. So thank you so much for what you do. I can't imagine doing 500 episodes of anything, and I don't know how you still come up with topics, and I can't wait to see the next 500. So thank you so much.
We'll do them. All right. Well, thanks everyone for watching. Thanks to Nancy, Susie, the rest of the WSH crew for organizing this amazing event. Yeah, you're gonna show everybody. And thanks for everyone watching us live. I'm not sure when the next actual episode of the Space Hangout is going to be. It's probably going to be in 2 weeks when I get back from the cruise with Paul. So we'll see you then.
And if you're figuring out what vacation you want to have next year, we're swapping it out. And I'm going to be taking people where it's hot and dry in the desert of the American Southwest a year from now.
Sounds good. All right. See you next time, everybody.